I feel like I've talked about vaults like 500 times in the last 2 months, and I assume maybe some of you have heard some of those conversations. So I don't want to belabor anything. So I'll try and give like a general overview without zeroing in on any one thing too deeply. But that said, obviously this is a small group. So if you have particular interest in any, one mention of this thing, stop me and we can drill in. But so I guess the story starts a few years ago when I started really thinking about custody systems in Bitcoin, kind of more from the industrial side. Obviously, probably like many of you, I hold coins myself, and it's always been a little bit unnerving, kind of the degree to which, unless you go to really Herculean lengths, you're kind of like relying on, a single piece of software or a single hardware manufacturer, even if you kind of roll in your own entropy to a certain extent. And obviously, organizations that deal in Bitcoin industrially have a similar problem, that's of a very like flavor, but, maybe in some ways more intense. So anyway, I've spent a decent amount of time kind of thinking about custody stuff. And, one of the things that you come across when you're thinking about custody stuff is this really old idea of vaults, which goes back to, I think, as early as 2013. There was a Bitcoin talk post that I linked to, I think, in the BIP that somebody proposed. And then Eamon Gunseer and Itai and some other guy wrote the well-known paper on covenants in Bitcoin, and they're sort of like, it's a weird paper because it's split into two sections. Really, the first section is like, hey, there are these things, covenants that we can do, which are basically just other ways of authenticating spends, that include looking at the broader transaction. And if we had this capability, we could do this vault thing where you encumber a coin in such a way that you can spend it anywhere you want to spend it, but there's this sort of delay period where if you find that the spend wasn't actually legitimate, you can claw it back or recover it, and we can use covenants to do that. And then they spend the second half of the paper like talking about Bitcoin NG or something. So this is an idea people have been thinking about for a while. Brian Bishop, I think, then figured out a way to do vaults without covenants, which is basically pre-signing a big tree of transactions with a key that you initiate and then throw away. And then he actually made use of CTV to do this. I have an implementation of that as well. And the idea there is that you can use CTV or even APO, just any way of kind of like using the chain to lock in a dependency tree or a flow of transactions. You can use that to remove the need to generate this ephemeral key, which is great because it turns out that like proving you deleted a key is basically impossible. And if you didn't actually delete the key, then someone can short circuit this vault structure and pretty much spend your coins however they'd like to. So I've been at NYDIG for the past little while here, and they're putting quite a bit of thought into their custody system and what it's going to look like going forward. And so having been privy to some of the details there, I've become very interested in how vaults can actually kind of practically be implemented. And so it kind of all of last year, I'd been watching the covenant discussion unfold and playing around with CTV, and maybe like many of you, a little bit discouraged that it didn't feel like we were making much progress toward any one solution. And I had been at Chaincode, and I think I had spoken with Peter and some other people kind of about the state of affairs. And Peter kind of expressed this sentiment, which I agreed with, which is like, we shouldn't be focusing so much on some general solution to covenants, because like that design space is just so wide open, and there are so many different trade-offs that it's hard to evaluate and make progress, on something like that. We should kind of come at it from the other direction, which is like, what are the things that we want to use covenants for, and how can we kind of get there? So for me, obviously, vaults is one of those. So I just wanted to write this like paper, kind of summarizing how vaults can be implemented, and then proposing a sort of like hypothetical benchmark approach that's like, okay, vaults have all these challenges. The ephemeral key deletion thing is one. Efficient UTXO management is another. So, you're depositing into this vault, potentially a number of times. How does the spend process work for all those separate UTXOs? You've got like kind of the difficulty of setup. If you have to do this like ephemeral key ceremony every time you're setting up, that's kind of a pain. You've got fee management, which is a real problem if you are using, even using kind of one of the covenant primitives like CTV. If you start to sort of harden this flow of transactions, then you potentially have to lock in, like which fee wallet you're using, or are we going to use CPFP anchors, or like kind of what's the approach there, and all that has to be determined ahead of time if you're going to use either the pre-signed transaction approach or the CTV approach. And then the other problem too with pre-generating the graph of transactions is like, okay, so now when you're unvaulting, the funds maybe have to flow through this like intermediate kind of warm wallet where you unvault to that target, and then you spend on to your kind of ultimate target. Mike, can you scroll down? It's maybe the second page. I think it's got like the basic diagram on there of how vaults work. So nothing totally shocking here. A user has some UTXOs they want to vault. They spend it into this vault construction. When they want to go and spend the coins somewhere, they trigger an unvault. And at any point before this unvault confirms, after some delay, the owner can sweep the vaulted coins to some predetermined recovery path. So maybe you could go down to page 5 now. So I came up with this, like at the time, sort of hypothetical approach for how to do this without suffering any of the trade-offs. How to basically do like efficient batched unvaulting. How to do flexible fee management, and how to avoid this like intermediate wallet problem, to set aside all the ephemeral key stuff. And so I came up with these opcodes, and I thought, okay, well, now I've got this kind of design. It'd be really cool if I could, try and implement it and come up with a prototype. And so I did that, and it actually kind of worked. This first design did some stuff that was pretty novel, I guess would be the charitable way of putting it, in terms of how the script interpreter does things. So as an example, like the way that you would specify your recovery path, you can see in that first box there, the outvault box, in the first parameter, you'd specify like a hash of the recovery script pub key that you could always spend to. And then, when you're spending into that recovery, you can kind of batch into it by spending a bunch of compatible vaults together into that, something with a script pub key that matches that hash. Another example of like some weirdness is that there's some recursive evaluation that goes on with this design where, let's see, how does this work? It's like when you're using the unvault authorization mechanism. So basically, like the script you have to satisfy to trigger an unvault. You're essentially like taking a script onto the stack, and then it's almost like an op eval type process. You're supplying a script that matches the unvault SPK hash that you provided in the opvault setup, and then you're actually checking that that script is satisfied by the unvault transaction. And so when I first came up with the implementation, the design was really rough, and like the op unvault had to be done in bare script, so you couldn't do the whole thing in Taproot, but it kind of worked. So I published to the mailing list and put the code out there, and then AJ and InstaGibbs started taking a look at it and kind of suggesting some obvious improvements, like kind of juggling some of the witness content so that we could keep everything in Taproot. And then we wound up doing a much bigger rewrite of the implementation, which I'll talk about in just a second. But another kind of interesting dimension of this first cut was I wasn't using CTV, but you can kind of tell in that last step there, where you're waiting, a certain delay, and you're ensuring that the outputs match some target hash that you specified in the op unvault, what's called the trigger output. So yeah, I guess maybe I should talk a little bit about this. Like, so when you actually initiate an unvault, you have to declare exactly where the coins are proposed to be going. So you're essentially doing like a content hash of the set of outputs that you want to ultimately withdraw the value of the vault to. And so I wasn't using CTV for that, but I wound up writing something I thought was a little bit simpler than CTV, but was actually basically just CTV after I fixed the malleability problems. So that was kind of another interesting dimension. One of the first follow-up mailing list posts about this was Ben Carmen going like, "Oh, cool, we can use this to get CTV by just spending directly into an op unvault with a 0 spend delay and an unspendable recovery hash, and I can finally get my DLC improvements." So it's that was kind of ironic to me that people just really want CTV pretty badly. So before I talk about like the current state of the BIP and the redesign, does anybody have any questions or anything they're confused about? Anything I can drill into, kind of about like the background, history, the goals? F in the chat.
Since you just mentioned CTV, like that, I listened to a podcast with you, the NVK podcast, and there you mentioned that you actually thought that it would make sense to deploy both CTV and opvault together. And like at the time, I had my hands full and didn't bother to get back and re-listen to it, so I don't really remember. I think you also didn't really go too much into the details, but maybe can you explain a bit more what like got you down this path to think this, and if you still think that's right, or if you're going deeper into this?
Yeah, definitely. So it's a few things, I think. Like in the course of implementing this change, it dawned on me that one of the like recurring primitives, I mean, and especially for vaults, you kind of need this, like this recurring primitive of you need to make a coin spendable solely under the condition that the outputs are a certain, set. And that's essentially like CTV just winds up being the most sort of primordial way to do that. And so I kind of found that in my own design, and then seeing that there were all these other uses for CTV. Like, I don't know how many of you heard about this TBD XXX thing, but Barack has this like new layer 2 design, and it turns out, CTV or APO emulation of CTV is sort of like a prereq. The DLC guys have all these things they want to do with CTV for efficiency. So it just seems like this kind of recurring pattern that comes up that's actually a generally useful tidbit that we can extract kind of and reuse elsewhere. Whereas I think like to do vaults, doing vaults like in a general framework is much harder because there are all these considerations around batching and there's kind of like special transactional structure stuff that has to be considered. Whereas like something like CTV is very simple and kind of repurposable. And so if you look at like the BIP 119 pull request and Jeremy's spec, it's very well tested. You know, it's been reviewed to the hilt. So I just figured it made more sense to sort of repurpose his work and honestly to pay homage to the good work that he did to come up with it. But I think another aspect of it is, as we'll see shortly, the new design is actually a lot more flexible than the one you see here in this graph. It's a little bit harder to get your head around initially, and it's a little bit more taprooty. But it actually means that this vault process can be composed with things that aren't CTV. Like, for example, if instead of like withdrawing to a particular set of outputs, if you just want to do like transfer all these coins in toto to this new key with a a check sig, basically, like you can swap that into the op vault usage without actually making use of this content hash thing. So I guess like the long and the short of it is that it just made a lot of sense to decouple CTV from the vault procedure per se. Does that make sense?
Yeah, cool. And maybe to follow up, like that's something that I've been thinking about a lot lately is, and I think was also mostly triggered by this Ben Carman post, is that really like I'm just not sure, like I'm fully on board with like going for like the use case that we want the most and make like the tightest possible proposal and go like step by step with the simple steps first. But really, like, since we have a composable script here, is it really possible, and are we really making it simpler? Because like, if I think now a little bit into the future, let's say we add up vault and only up vault, and then the next thing is, I don't know, like something else that is very tight that gives us the next use case, whatever, like something like TX hash or something. And then like once we have it, then somebody discovers, okay, if I combine vault and TX hash together in some weird way or so, it gives us something super weird that we didn't anticipate. And so this is really why I'm not sure if it really gives us less complexity than like general proposal where we just look at all of the options at once and come to a conclusion that it's safe, all of it completely. Whereas like every time we add some small step, like we get like this exponential additional stuff, and maybe like focusing just on the small steps and like keeping like the like a narrow view on these things maybe lets us not see like something that is very complex and then becomes like a big issue.
Yeah, so you're talking about, I think, I guess there are two prongs to what you're saying. Number one is that perhaps something very specific like OpVault can be combined in the future with something and create this kind of crazy unexpected behavior that causes problems. And or maybe something more general could solve the OpVault problem as well as, let us hit whatever kind of future use cases arise. And I think that's definitely a legitimate line of thinking with a few caveats. So number one is like, people have been trying to think about how to do this stuff for a while. And I mean, I've been thinking about vaults for a few years, and I'm not the end all be all authority on this by any means, but it's like, so the behavior that's kind of outlined in this paper in terms of the batching and kind of flexibility, like that's not possible with any of the outstanding kind of generic proposals. So one of the things that I wanted to pull up at some point was Barak's attempt to emulate opvault with the elements introspection opcodes. And it turns out he got most of the way there, but he wasn't able to do something called revaulting, which is where it's essentially like a partial withdrawal from the vault. And so like these general mechanisms, I think it's certainly conceivable that you could kind of get pretty close. But then you're paying the cost of a pretty big on-chain footprint, as well as a lot of script complexity. The script complexity, I guess, is less of a concern because you can do testing and whatever else. But I mean, formally verifying Bitcoin script is pretty difficult, I think. So, yeah, I mean, I think people have been trying to crack that nut for a long time, and are still trying to crack it. And you know, one of the most interesting proposals out now, I think, is from Salvatore at Ledger with this like MAT, the Merkleize all the things proposal, which I think is now kind of a misnomer because when he tried to emulate opvault, he's not using any kind of Merkleization. But like, so even the MAT emulation of vault is like, yeah, I haven't quite figured out how to like do the batching because we've got to do these aggregate amount checks. And yeah, I'll figure that out later. Like, oh yeah, I haven't quite figured out how to do the revaulting, you know. So I have yet to kind of be presented with like a usage of a more general framework that can actually achieve this. And then even if that worked out, like you got to deal with the heavier on-chain footprint and the script complexity. So I think it's definitely worth considering, but yeah, personally, I haven't seen anything that's kind of persuaded me against an approach like this. Yeah, so this is a really interesting and fun walkthrough of the usage of the elements introspection opcodes. And what he winds up doing is like using that n+2 input to do like some kind of batch check over all of the inputs. And then I guess he hard codes some kind of like fee slot in there. It's just like, it's a little bit fiddly, but it's a really interesting, it's a testament to how smart he is in terms of using script. But I think it's a little bit fiddly and it hard codes some stuff. But yeah, one of the interesting dimensions of the opvault change, which we can talk about, is this framework I'm calling deferred checks. So Mike, maybe you can, no, it's probably not worth opening code, but one interesting thing that this opcode does is it like to facilitate batching, it allows you to take inputs that have compatible opvault parameters and essentially batch trigger them into a single withdrawal trigger output. And that creates a bunch of on-chain efficiency because if you've got a bunch of different deposits, you want to be able to kind of withdraw them in bulk. But to do this, it winds up like from a script interpretation standpoint, you have these, you know, multiple input values going into a single output value. So you can't use the existing execution model of the script interpreter, which is let's evaluate each input independently, perhaps in parallel, and then make sure, you know, if they all check out, then we're good. You have to do this thing where you create what I call deferred check, which is like, okay, I want to make sure that this batch output has at least, you know, this input, and then you aggregate all those together, and then you ensure that the amounts check out. And this is actually something that you would have to do if you want to do like signature aggregation, right? So it's sort of just a general framework for aggregating some kind of operation over a bunch of inputs. So that winds up being kind of a vault, like the specific kind of deferred check winds up being unique to this triggering process a little bit. I mean, you can go and read AJ and Greg's proposals for making these into more generic opcodes with names like op partial forward and a few others. But I just think they're like, they're reaching for a genericism that isn't really meaningful, because you just wind up using this stuff for vaults, and it's very specific to this kind of workflow. So Mike, maybe we can crack open, if you could just go to bip345.com, which NVK charitably set up for me. So if you go to files change, and then can you click on the ... for the MediaWiki file, and then view file? Yeah, it's gonna be easiest. So this is the BIP, the introduction, the goals, the design stuff. That's all background that I just kind of gave you. But maybe if you click on transaction types and design, and then scroll up a little bit, I think there is a really schizoid looking, yeah, okay. So this is like the graph. If you can understand and parse this thing, you kind of understand the new formulation of the proposal, which Greg and AJ are largely responsible for. And the idea was that, like, instead of having this flow where we have an op vault encumbered output that then flows into this op unvault encumbered output, which then flows ultimately into the final outputs. The idea here is, instead of doing that with all this like kind of indirection around like, oh, what's the hash of your recovery path, and like what's the hash of your unvault trigger script, the idea is like basically move all of that into the tap leaf tree. So that now when you're executing an op vault instruction, all it's really doing is checking that you've replaced that tap leaf with some kind of templated tap leaf that's contingent on parameters that you both kind of curry in that tap leaf as well as specify in the witness. So you do this like kind of, I don't want to call it a partial function evaluation because it's like way too big brained, but in this example here, we're basically saying, okay, you've got your op vault. I'm looking at the green tap leaf right now. You've got your op vault, and that quoted script fragment there is, oh, thank you, Mike, that's nice. That quoted script fragment there is what we call the script body update fragment, or something like that. I've maybe a less ham-fisted name for it. But the idea is that like that's the body of the script, and then the 2 there is saying, okay, I'm going to pop 2 additional parameters off the stack, and then append them in the same order to the end of that script. So in this case, we specified a spend delay here that's going to get thrown in there. But you'll notice that it's still, this instruction still has 1 thing to pop off the stack that we're not going to pop yet. And then we've got the trigger off script fragment here, and that's the script that you have to satisfy to actually initiate the unvault process. So what's nice about that is like that was previously specified as some hash that you then had to present kind of like a pay to script hash type thing for, but now it's just embedded in the tap tree. So there's no indirection, which is cool. So then when we're spending into number 2, this trigger process, you're just doing this like tap leaf update verify thing where you're validating that the new tap leaf is this CTV construction with the CSV in front of it. And that CTV hash then you've given in the witness to the withdrawal transaction. So that's when you're kind of declaring, hey, this is exactly where these unvaulted funds are proposing to go. And you'll note that the opvault recover leaf there has stayed intact. So the idea is like the whole rest of the tap leaf tree just stays exactly as it was. And all you can do with opvault is just update that 1 tap leaf in the pre-formatted way. So obviously both the trigger and the initial vault are both recoverable with the op vault recover, or they're spendable by the internal pub key, which like you can do a number of things with. That could either be, you know, a key that's correspondent to your recovery path, or that could be a nums point that's not spendable. It kind of depends on how you want to set it up. And then kind of the third transaction is a very straightforward use of a time-locked CTV. So the implementation of this actually wound up being more concise than what I had originally done. It doesn't introduce any recursive script evaluation, which is a real win. And interestingly, it's composable. Like, as you can see, instead of doing the op CSV, op drop, op CTV template, you know, you could just do like an op CSV, op checksig, op drop, op checksig template to delegate the coins. You know, if you wanted to do like an inheritance scheme where your kids have a certain key, you know, you could have like multiple leaves in there that even perhaps have different time locks. And can be triggered by different keys. I was talking to Alex at River, and he was saying one of the most interesting things would be like on the recovery path, you have a whole granularity of things you can do for recovery. Like, you know, if you want to, let's say maybe River. I don't know if River's doing this, so don't, you know, quote me or whatever, but if you're River and you're like, okay, we want our recovery path to point to our, you know, initially spendable by our like super secure Codex 32 offline generated key, that's great. But then let's have another tap leaf in the recovery tree be like a 6-month time lock delay that's spendable by a multi-sig consortium of like sort of friendly industry partners, so that if for some reason, egg on our face, we really screwed up our super cold key generation and we can't recover for whatever reason, you then at least can fall back 6 months later. So so like this is really kind of exemplifying the power of Taproot in my mind, and the new formulation of the proposal, I think, you know, really shows off how flexible and simple it can be. So in terms of future work, maybe you guys can tell me how cool or not cool you think that this might be. But there are a few things that we could do by adding additional opcodes, and I'm kind of going back and forth with AJ and Greg about the use of these things. But one of the things is having like an op vault collateral decorator, where in that script fragment you basically say like op vault collateral, you know, 10 Bitcoin, and then in order to trigger a withdrawal process, you would have to post 10 Bitcoin of collateral that has the same exact sort of trigger structure as the vault, with the idea being that if you're an attacker and you want to try and unvault this stuff, you post the collateral, but the collateral is also sweepable by the recovery. So if you wanted to try and, you know, hack the funds or whatever, you'd lose some of your own, which is kind of interesting. I think it's cool. I think there are some real questions around like operational complexity there. You know, are you using the same infrastructure to do collateral posting as, you know, as everything else? So maybe making it useless, but maybe if you're a big company, maybe you can afford that kind of thing. I don't know. And then there's like Greg has talked about like on-chain rate limiting of withdrawals. You could imagine that you could decorate this in such a way to make that work. I'm not so wild about that, not because I think it's dangerous or whatever, but I just, you know, I wouldn't do it. So just to touch really quickly on like end usage considerations, I think the upshot of this would be, I mean, this is kind of a usable interface for wallet implementers. It's not the easiest to reason about, but you could see putting some kind of like mini script API around it that could make it, you know, that could sort of codify like the recommended usage in terms of, okay, you specify a descriptor for the internal pub key that, you know, corresponds to recovery path, so that every time you know, vault to this thing, you're not doing address reuse, stuff like that. But then obviously to get the benefits of this, you need to run some kind of a watchtower process. So you need to have some software that's sitting there, kind of just looking at the chain to make you aware of potential spends. I guess. Oh yeah, the other thing I should mention here is that in terms of fee management, what's cool is this is kind of wide open. Like you can do batching, and as long as your recovery authorization is non-zero, you can basically bring your own fees for everything. So you can mix this in a batched way to kind of any transaction and sign say cash all, so that you can bring your own fees. You can do CPFP anchors, like kind of whatever you want. When in the beginning of this proposal, it was totally reliant on the wonders of V3 and ephemeral anchors and all that stuff, which is still obviously great stuff, but now the design is a little bit more flexible in terms of the fee management story. So I think things are pretty solid there. So yeah, I've probably said enough and scared you considerably with this schizoid diagram. So I'll pause again for questions. Nicholas.
Do I need to know the recovery SPK hash to create a trigger transaction?
Yeah, so you need to know, in order to create the trigger transaction, you need to present the Taproot control block to actually initiate this. So I guess like what you could do is you could, if you wanted someone to be able to trigger without knowing the recovery path, you could just give them the control block they need, which is like
by control block, you mean the script, the leaf itself?
It's like the control block is like the path to the particular tap leaf that you're spending.
Oh, okay.
Yeah.
So just the hashes, I guess, for the path.
Yeah. So it fully commits to the tap tree, but it doesn't reveal the other leaves. So if you wanted someone who wasn't privy to all the structure to be able to trigger, you could just give them that path and they'd be able to do it.
Okay.
Does that make sense, or still kind of murky?
No, that makes sense. Yeah.
Okay. Cool. Because yeah, I think that's kind of an interesting use case. Like that inheritance use case is kind of interesting. It's like, okay, you want to give your kids or whatever enough information to be able to trigger that inheritance process, but maybe you don't want to give them the whole thing for whatever reason. But even then, so like even if you gave someone the whole tap tree, that's just telling them kind of like what the SPK is.
Okay. And another question, maybe that's a dumb question, but why do we need the recovery leaf if we could just use the keypad spend?
Yeah, so the rationale there is like, if you have some really cold keys on your recovery path, you don't want to have to like dig those out to sweep to recovery to like actually spend. That's why this op-vault recover opcode was introduced, because it lets you spend solely on the basis of the amounts going into something that matches the SPK hash, because otherwise you got to sign with something. Either you have to sign with something, or if you were to use like a CTV type thing, you would have to commit to the amounts and so forth. So this op-vault recover is like another kind of covenant that basically just says like, you can spend, it does a few things. It's like you can spend into an output that matches this SPK hash, and it allows you to do aggregation of the separate vault inputs. So it actually queues up those deferred checks across all compatible op-vault recover usages. So like, again, to kind of get back to your question, like if you just had the internal pub key usage for recovery, you would have to like sign with something. And the internal pub key can't be by taproot edict or whatever, it can't be like a script. It has to be a key.
Right. That makes sense.
Yeah. So the idea, yeah. So we want to be able to recover like immediately without having to dig anything up.
Yeah. Thanks.
For sure. Mr. Hebasto.
James, can I ask you to elaborate a use case for inheritance planning?
Yeah. So, you know, if something like this were deployed, and if I had, you know, kids of age, or maybe not of age, I don't know, maybe I should be thinking about this, but what I would probably do is when I buy coins on an exchange, I would likely have them withdrawn into a vault structure where, in order to spend from, say, my cold card, I have to wait like 10 blocks, and then I can spend to wherever I want. Alternatively, I could trigger a withdrawal to, say, like a device or a key set aside for my children, but I'd have to wait like 6 months worth of blocks for that to happen. So the idea is like you can append on these conditions, all of which like can be initiated, but you know, if my kids try and take the funds, you know, before I'm gone, then I'll recover them, you know, back into keys that I control. Does that make sense?
So recovery path is not for heirs, but for initial owner, right?
Yeah, exactly.
Oh, yes. Thank you. That makes sense.
Of course. Yeah. Sorry if I sound like I'm hungover. I'm not. I'm just kind of dragging this morning. Fanquick wasn't in town, so I couldn't possibly be hungover. Anything else? I'm trying to think about if there are any other dimensions to this. I encourage you, if you're at all interested, take a look at the implementation because it's simpler than you might think. I don't know, maybe it's more complicated than I think, but I think it's pretty followable. And there's a lot of, there's a kind of scary but comprehensive functional test written for all this stuff. I'm hoping that in the next maybe month or so, we'll kind of nail the spec down and get it merged into Inquisition, pending AJ's blessing. And then I want to write some, you know, demo wallet software to use it. And then who knows? Nicholas.
I don't really know what the use case would be. Like, could I have multiple trigger and recovery leaves in one output? Or
Yes.
Okay.
Yeah, you could.
I don't know what that would give me. Just curious.
That's what's kind of interesting about the tap leaf approach is like previously it was like very rigid in terms of like, okay, you get one recovery path, you get the one, you know, sort of unvault trigger path. But now it's like, yeah, you can have a whole, like you could have an arbitrary number of these things in there. And so for me, like the big win is this vanilla, you know, use case in front of you. Like, I just think that'll make a huge, huge difference. I think for pretty much anybody holding Bitcoin. But yeah, you can imagine like more complicated usages. I just can't think of kind of like what the use cases would be. This just wound up being like a simpler way to kind of do things.
Wait, it says allows templated replacement for the like first leaf, I guess.
Mm-hmm.
Does that allow for other covenant type things? Or?
Yeah. So that's the cool thing is if we come up with something that's, you know, different than CTV, maybe it's TX hash or whatever in the future, then this vault flow can be used with a different update template, and so you wouldn't have to change anything about the way that opvault works per se.
Would that require like 2 soft forks, one for the new opcode? Okay.
No, happily, yeah, no. So you can just drop in. It would require updates from the wallet implementers. They'd just be specifying a new template in their usages of opvault.
Okay. So I could also just not use CTV with this design and use whatever I want.
Yep. Yeah, you could. So theoretically, this could be activated independently of CTV, but then the way the triggering process would work is like you would have to go into a warm wallet instead of going directly to your final destination, unless you wanted to like transfer a whole coin to somebody. But yeah, so what you would do then is like instead of that opctv there in the update template, it would be like op checksig, and then that would just point to a key that you control as your like staging wallet or warm wallet or whatever. So you'd have basically the upshot of that is like an extra UTXO and an extra step in the process. But yeah, you could just deploy this without CTV. I think it's way more useful with CTV, especially if you think about like just on-chain volume. But yeah, you could definitely do it with just checksig. Anybody else? Are there just as a question for the audience, are there other Covenant use cases people are really fired up about? Nobody's fired up.
I mean, the obvious answer is like improvements of Lightning, like APO, for example, would do.
Yeah, so the story on APO is very interesting. I've spent a decent amount of time trying to suss out the hunger for APO, because like, so CD is here, so he can opine, which is great, because actually I've been wanting to talk to you about this. Like 4 out of 6 times, okay, I could have just said 2 out of 3 times. 2 out of 3 times I talked to a Lightning dev. I'm like, all right, so APO, like maybe we do a package deal soft fork with APO, CTV, and opvault. And I'm like, how excited are you about APO? And they're like, well, I think like LN-Symmetry is cool, but like it's definitely not highest priority on my list. Like I want PTLCs and or something else. Now some people are like, oh yeah, no, it'd be cool to have. But oftentimes when LND Slayer put out his TBD-XXX design, this layer 2 he's working on, he initially said he needed APO. And I was like, bro, you're just synthesizing CTV with APO, which is less efficient, because if you want to do the CTV thing with APO, you wind up specifying, your 33-byte pub key, and then your 64-byte signature, or 65 bytes, something in that neighborhood. Whereas with CTV, you're just given a 32-byte hash and you're off to the races. So anyway, I guess Christian, can you phone in and like how important is APO to you?
Obviously, to me, it's quite important, being the author of the original BIP. But I think we sort of figured out that we shouldn't be adding too much pressure. I wanted to make it very clear back when I wrote that BIP that we're not sort of aiming to push it through as a standalone thing that needs to have a review cycle on its own, and basically make it as easy to slip into a bundle as possible. Because we know we just went through the SegWit and the Taproot activations, and so no, the Taproot activation wasn't done by that time yet. But they took a lot of time, and we didn't want to sort of impose onto others. Also, there is an unwritten rule apparently that the author of a proposal cannot be its champion, and as such, I refrain from pushing too hard, because that's when you sort of get resistance as well. I think most LN developers do expect something like APO to activate eventually, whether that's APO or CTV plus checksig from stack is sort of, I mean, it would hurt my ego, but other than that, we would get the functionality that we need, right? Yeah, I don't think that that it has to be APO. What I disliked about Jeremy's proposal back when it was opctv was that it was being presented as a standalone replacement for APO. And that's not true, because you need opchecksig from stack, which happens to be quite the probably the broadest proposal out there, which would probably get the most pushback. And so I turned around and figured out that you could use APO for a lot of the use cases that CTV was out there as well. So there is definitely some overlap. Whether we need both, I don't know. But we probably want one or the other.
I think
which one it is, who cares? As long as we get the functionality, we don't care. As much as for enthusiasm, I think Lightning is pretty quick at evolving, and it's kind of hard to stay up to date. So I think there is a certain happiness about this not being on the urgent side of things. Hence why most people sort of go, oh yeah, we'll have it in a couple of years. There's no pressure. But I think most people would agree that that new sort of fun toys to play with are something that we should work towards.
Yeah, I think it doesn't need to be mutually exclusive. I think APO and CTV are both very simple changes that I think can coexist. I guess the conclusion that I've kind of arrived at is that, though, the unique use case for APO, so far as I can tell, is basically LN-Symmetry. And I think
you can do almost the entire list of Jeremy's use cases, like the deferred payment structure that he had for payouts from exchanges that you can do with APO. There's quite a bit. I went through the entire list, and I think it was one use case that I couldn't come up with a scheme in the 5 minutes that I looked at it. But
I guess my point is just based on efficiency. If you had both, the one thing that you would want to use APO for is LN-Symmetry, because otherwise CTV is lighter. It's lighter in terms of computation space. But maybe, so what I'm trying to suss out, and I'm very friendly to APO, is LN-Symmetry compelling enough from the Lightning community that we should push for APO as a soft fork? And that's, I would love you to be more vocal.
I mean, I don't know. I haven't looked into it from an efficiency point of view, so I can't tell. Yeah, no, I probably would have to look into it a bit more. But like I said, it's everybody's kind of happy that it's not on the urgent list right now.
Cool.
And I mean, we're trying to be respectful of everybody's time, right? The core team is very busy themselves, so if we were to sort of push our agenda onto them, all we would get, and that would be the right reaction, would be sort of pushback.
Everybody's kind of like, we're wandering in the desert. There's not a super clear path forward, and probably the more involvement and engagement, on that, the better. Yeah, Gloria is asking about what are the most important use cases from Jeremy's list. Don't feel like congestion control. Yeah, when Jeremy first presented, he kind of led with congestion control, and that didn't excite me very much either. In hindsight, congestion control could be kind of interesting if we hit a situation where, like, there was a lot of talk about the mempool being empty later on when the subsidy runs out. And if you had a way, like, congestion control could kind of allow you to smooth the fee market, like distribute transactions over time, because it provides a way to commit to something without actually initiating it. But I agree with you. It's not super exciting to me. And this is another one Christian can weigh in on. I think one cool, albeit speculative, use of CTV was the one-sided channel opening. So if you walk into some merchant and you can kind of like you can commit to having opened a channel with someone, push a balance without them having to sign anything. I think that's kind of cool. But for me, like, why I didn't like come out guns a-blazing for CTV was that the one use case I really think is going to move the needle is, well, the two, I guess, are vaults and coin pools. And CTV like kind of gets you 80% of the way to those things, but it doesn't knock anything out of the park. Whereas it kind of seems like prerequisite or like a component, either CTV or APO to do some of these efficient usages like vault and coin pools. But yeah.
So I don't remember how, but there was a possibility to implement that one use case, which I don't remember what you just mentioned.
The one-sided lightning thing.
Sorry, yeah, the one-sided lightning open. There, I had a draft for it somewhere. Probably should look it up. But it's this is me shilling APO, by the way, so heads up. But the whole LN-Symmetry thing is pretty much an enabling technology for a lot of other things, right? I had so there is, for example, the possibility of having multi-party channels all of a sudden, which can get quite interesting. I had a post a couple of years ago about reconciling off-chain and on-chain, where it essentially turns out that by separating the update mechanism that is implemented using APO from the applications that we build on top, we can actually reunite or rebuild or recreate the entire logic that we can build on-chain, off-chain. And so I find that quite compelling, and things like channel factories and so on. So while LN-Symmetry might sound simple, it does enable quite a few different use cases as well, which is true for CTV too, by the way. So
you're absolutely right. And multi-party channels, channel factories, those things start to kind of resemble coin pools. Like, yeah, they start to become kind of the same, hit the same usages, which I think is awesome. And that's, if you had to pick sort of a scaling problem to solve, that might be it. So I think that's tremendously important too.
Yeah, I mean, the whole idea of reconciling on and off chain was essentially that, hey, we now have a new environment that follows the same rules of on-chain, and all of a sudden we can re-implement all of these operations off-chain and just have essentially build up trees of transactions on top of a shared of a commonly controlled set of outputs. We can build up this tree of transactions, and every once in a while we just come in and sort of collapse it into back into its state, and that resembles very much the cut through that you can do for Mimblewimble, for example. Mm-hmm. And all of that you can do off chain, and essentially all of a sudden almost everything you can do on chain you can do off chain, with one exception, and that's short-lived timeouts that are below the update horizon. But other than that, you can pretty much build, since we're using the same language that we're using on chain, you can express everything that you can express on-chain as well as off-chain.
Yeah, it's very cool. I mean, if we can solve that, that'll be massive. I think that the difficult part with those schemes is always as you open up, as you generalize from bilateral to multi-party, how do you handle someone becoming non-interactive? You know, how do you do the exit conditions properly? And that's what tempers my enthusiasm a little bit about the coin pool stuff is like, I just haven't seen a proposal, even theoretical yet, that kind of bridges that gap. But I'm hopeful.
It's worth wondering if it is a fundamental trade-off in all of this, right? If you want to mandate that we have shared control over outputs and then suddenly one of us drops off, then we either reduce the security and add a mechanism to kick them out, or we are stuck. And that is a very common sort of trade-off that we have in distributed systems from literature. So I'm not sure we are going to find a solution for that. Maybe there is a way for us to passively filter out people that have become unresponsive. But unless we want to weaken the, hey, everybody has to agree on state changes requirement, we might not be able to work around that.
Mm-hmm. Mm-hmm. Well, I'm glad you're thinking about that stuff, and you should continue to think about that stuff because it's really, really important, I think.
Yeah, and I definitely look forward to your upvolt proposals again.
Thanks.
These look amazing, and to be honest, so much easier than the initial ones.
Yeah, I was gonna say I wouldn't describe this chart as looking amazing, but I mean it's conceptually I'm pretty happy with where it's at. You might wonder why that green arrow is fat instead of thin, and initially it was thin, but AJ said I wasn't typing my arrows properly because this is a taproot transition and not a transactional transition, whatever that means. So, but
oh yeah, we definitely need Merch's nomenclature bib.
Yeah,
so that everybody uses the same terms.
mm-hmm.
It's been quite confusing in the past.
And then a graphical equivalent.